Continuing on with section 5.1, we just mentioned that sometimes a capital letter is used to represent an event, and we talked about sample space and events. And now we're going to look at Venn diagrams. A Venn diagram is used to illustrate sample spaces and events within them. When you're doing a Venn diagram, the sample space is represented by the rectangle, and the events are shown as disks inside of the rectangle. And when you talk about this sort of Venn diagram situation, it's a given that you're going to land inside the box. Remember, the sample space is the set of all things that are possible, so we're representing all the possibilities with the box, but only some of those things meet our event, and we show them inside with the disk. So a Venn diagram can be used to illustrate a basic probability event like that, but it can also be useful to illustrate new definitions of probability. And we're going to look at one of those right now. That's the complement of E, or not E, and that's the event that E does not occur. So if you thought about that one, where would we shade if we wanted to say that event not E happened? And we know we have to land in the box, but E didn't happen, so we're not in the circle, so we would shade everything that's in the box, but not inside of the circle or disk for E. So not E would look something like this, shading all possibilities except for those that are inside of the disk for E, but staying inside of the box at the same time. Alright, so that's a little bit with the basics of Venn diagrams. We'll use these again later to illustrate some more complicated probability ideas. Let's go ahead and practice this new definition of complement and some more basic probabilities by moving to an example with a deck of cards. So consider a deck of 52 cards. Our experiment is going to be select one card at random and consider the events listed below, and then find the probabilities listed below that. So the events that we're going to be working with is A, the card is a jack of spades, B, the card is a jack, C, the card is a spade, and D, the card is a face card. And then they want us to do probabilities. So as we go through to do these, the probability of event A, the card is a jack of spades. Since we're selecting a card out of a standard deck of 52, our denominator would be 52, and then the numerator would be the number of ways that A could occur. So we need to think about how many jack of spades are there in a deck of cards. So in a standard deck of cards, there's going to be only one card if you specify the denomination, which would be the jack, and the suit, which would be the spade. So if you take the denomination jack and the suit spade, that's going to narrow it down to a single card. So that's going to be just 1 out of 52. And I'll go to a decimal for that in a moment, but let's go ahead and get all our fractions done first, and then we'll bring in the calculator. For the probability of event B, we want the card as a jack. And again, we're choosing out of 52 cards. And out of those 52 cards, how many of them are jacks? Well, when you just say jack but you don't say the suit, then it could be any suit. So we would count the jack of spades, but we'd also count other jacks like the jack of diamonds as well. And it turns out that if you mention a denomination but not a suit, that always gives you 4 cards. And that's true whether you're talking about jacks or eights or queens or some other card. If you just say the denomination only but not the suit, there will always be 4 cards that meet that description. And by the way, for those of you that maybe are not familiar with a standard deck of playing cards, there is a brief description of those and a photo of all the cards so you know what's there in the book. And you don't need to memorize all that stuff. You can reference that page whenever you need it for homework, and I won't ask questions that require knowledge of what's in a deck of cards on the test, so you don't have to worry about that. Alright, so we've got those two done. Again, we'll come back and do the calculator part in a moment. Let's move on to part C. The probability of C, the card is a spade. So again, choosing the card out of 52 from the deck, so our denominator is 52. And when we start mentioning just a suit only, then we don't care what the denomination is. So we'd want that one because it's a spade, and we'd want this one because it's a spade as well. And it turns out, if you were to look at that chart, or if you know a deck of cards, once a suit has been specified, there's going to be 13 of those. So this would be 13 out of 52, which happens to be 1/4, so that's going to be 0.25 exactly. You don't need the calculator for that one. And then let's see, the probability of D, the card is a face card. So we'd have 52 cards for our denominator, and then we'd want to count all face cards. And there's a little bit of controversy for this. So face cards are cards that have the face of a character on them. So the Jack has a face on it, the Queen has a face on it, the King has a face on it. We wouldn't count a card like an 8 because there's no face. It's just the number 8 and then 8 clubs showing rather than a character. It's a common misconception that an ace would be a face card as well, but if you look at the ace also does not have a face on it. It just has one spade shown in the middle as opposed to the 8 clubs we saw a moment ago. So jacks, queens, and kings are all face cards, and we mentioned before there's 4 of each kind, so there's 4 jacks, 4 queens, 4 kings. So this would be 4 plus 4 plus 4 plus 4, or 12 out of 52, and we'll go to a decimal on that one in a moment as well. And let's go ahead and look at the final one before we bring in the calculator. So the probability of not C, so the card is not a spade. So the way I would do that one is I would look back up here and say, okay, when we were asked how many things were C, we knew there were 13 of them that were C. So that means everything else except for those 13 would meet what we want. So I'm taking the whole deck of cards, I'm subtracting out the spades because it says we don't want those. And so 52 minus 13, 52 cards minus the 13 spades leaves everything that's not a spade, which it turns out is 3/4 of the deck, or 0.75. And then just bring it in the calculator to get the decimals for the rest of those. 1 over 52, 0.0192, 4 over 52, 0.0769, and then finally over here the 12 out of 52 would be 0.2308. On every one of these I am rounding to 4 decimal places, so I'm looking at the 5th, and in this case that was a 6, so I rounded that 7 up to an 8. Alright.